people that I'm about to introduce to you, I can promise you that you will have a very, very different experience this afternoon. If I were to do justice to the impressive CVs of the two panelists for this afternoon session on support resources in mathematics education, it will take up most of the time for the session, which is not really what we're meant to be doing. So I had to limit myself to a few key achievements and interesting facts about them. So the first speaker will be Birgit Pepin. She has not only 26 years of experience in the UK, but also having worked in many countries internationally and served on many advisory panels for professional development as well as resources in general to support curriculum materials. She gained her PhD in mathematics education, which was sponsored by the ESRC from the University of Reading, exploring mathematics teachers' pedagogic practices. And after teaching at Reading, she worked as a research fellow at the Open University and later became a senior lecturer at the University of Manchester, where she also developed a mathematics education module for the MA and MSc program. Up until recently, she was professor of mathematics at the University College in Trondheim, Norway. But very recently, from the 1st of January, she moved to Eindhoven, where she took up to be the professor of maths education and STEM education at the University of Eindhoven. Birgit has published numerous articles and books with the main focus on teacher pedagogy and curriculum materials. She's done a lot of work on comparative studies in classrooms in England, France, and Germany, and in particular, to help her identify the underpinnings and cultural and educational traditions that shape pedagogical practice. More recently, she's extended her research to investigate student identity, the constitution of self as a student, but also as a mathematics learner, and in particular focusing on the transition between upper secondary and moving into university studies. So Alison Clark-Wilson works as a research fellow at the London Knowledge Lab at UCL's Institute of Education, and she's currently also co-principal investigator for the Nuffield Foundation's Cornerstone Maths project. Prior to this, she was at the University of Chester, where she led and designed postgraduate courses and projects for practicing secondary maths teachers. She's actively involved in a number of key mathematical associations and on the executive committee of the British Society for Learning Mathematics. And she also taught on the AIMSEC program that Tony referred to this morning. Alison's research focus is the development of innovative pedagogies and the use of mathematical technologies and how technology has become a powerful tool in advancing the cognitive understanding of mathematical concepts. And this is also the main topic of a recent publication, The Mathematics Teacher in the Digital Age, which she co-authored. I think you will agree with me that they're both very well qualified to talk on this topic this afternoon. But for me, if not as important, maybe even more important, that besides their research interests, they have something else in common, and that is their passion for mathematics education, which I have absolutely no doubt you will feel in the room this afternoon, and that this passion of theirs will also inspire and ignite a number of fires that will make for some stimulating debate this afternoon. So I'll hand over to Birgit, who's going to start.
Yes, what I would like to do is really to make the link and to link to Malcolm's presentation this morning, and then the link between Malcolm's and also Alison's. So I will definitely talk about professional development, and I will also, to some extent, talk about e-learning, not e-learning, but e-materials, basically, e-based materials. Okay, so resourcing mathematics teachers' work, the potential of curriculum materials and textbooks. Resourcing is purposefully written in that way because Jill Adler has coined this term of resourcing teachers' work. And of course, what she means by it is to help teachers in their work and to provide resources and support to help them in their daily work. So the structure of the presentation will be roughly like I outlined here. What are resources? Mathematics resources in and for teaching. My particular interest is teachers' interactions with curriculum materials, and of course there are frameworks that have been developed by colleagues, by researchers, and we may want to talk about this but not too long. And then finally on textbooks and mathematics teachers' work. What are resources in mathematics education? In one of our recent publications, we defined mathematics teaching resources as all the resources which are developed and used by teachers and pupils in their interaction with mathematics in and for teaching and learning, inside and outside the classroom. Resources are essential for mathematics teachers, and teachers use different kinds of resources which shape the mathematical content presented to and used by pupils in their mathematics learning. Moreover, when appropriating resources, teachers adapt them to their needs and customs. This process of design and interpretation of resources then continues in use, that is also in the classroom. Hence, transformation is seen here also as design in use. So, what are the mathematics resources that we have in and for teaching? So there are text resources, and we know all about these, and we'll come back to that later. There are, of course, mathematical tools, and maybe Alison might talk about some of these, and they are designed sometimes and used by teachers and pupils. They're developing resources, developing in a sense that maybe 20 years ago we had different resources and more mechanical resources. Now we have digital and ICT resources. We have also this, what I call manipulatives, maybe also representations that we use in a mathematics classroom. And we must not forget the personal resources. That is, for example, if a teacher talks to a colleague and they gain some new insights in something, that is also a resource. And so are, of course, pupils. Many teachers, when you ask them about their resources that they use, they say their pupils in the classroom. So our interest, my interest, and I've worked with colleagues in France and in other countries, is teachers' interaction with curriculum materials. And curriculum materials are not only textbooks, but of course also the teacher guides and the materials that teachers develop or download sometimes from the web, etc. So this interaction between teachers and resources has been theorized by many people. I will just outline selected frames here, but I think the underlying idea is really that teachers interacting with resources means that the resource acts on the teacher and the teacher on the resource. So it's not a one-way process, but it's actually at least a two-way process. And it's difficult to research that in some ways because, yes, of course, if the resource changes, if the worksheet changes, you can follow it on over a period of time. The teacher, you need interviews. Maybe you need other representations to show in which ways the resource had an influence on the teacher. So methodologically, this is not an easy task always. So here, we're trying to understand the relationship between the curriculum resources, the teachers work with the curriculum resources, and in which ways teachers learn when they work with curriculum resources. In some countries, and it was mentioned before, some of the, for example, work with textbooks and so on is part and parcel of teachers' daily work and working with their colleagues. In other countries, it is not. So the main interest is really this side of the triangle. But of course, the underlying final aim is the quality of instruction in order to support and enhance pupil learning. These are some, for example, well, just two of the frameworks. One is the documentational genesis developed by Guidet and Trusch in 2009, where you see the instrumentation and instrumentalization process, which is really this dual process working not against each other, but working at the same time. Janine Remillard has also developed a very elaborate framework for teachers interacting with resources, which is based on teachers' design capacity, which was a term coined by Brown in 2009. I don't want to go deeply into those, but I want to tell you about the study that we did with French and Norwegian teachers, where we asked them to draw their resource systems. And here you see a resource system of one of the teachers that we interviewed. And this is interesting, this kind of tool to understand teachers' resource system, because it is not only the resource system itself, the parts of the system, but as a system, and Mike linked to complexity theory, we know that a system has, it's a connected thing. And so how in the ways that teachers actually connect the different resources is also of interest. Teachers and mathematics, the international textbooks and mathematics teachers' work. Well, we know from many studies that the textbooks have been and probably are still part and parcel of teachers' daily work in the classroom and also out of the classroom in terms of preparation, lesson preparation, and so on. I've listed here some of the work where textbooks have been studied. For example, how do textbooks get developed? For example, in this case, in China. The links between textbooks, and we heard this morning from Mike about the intended, enacted, and the assessed or evaluated curriculum. Well, here we looked at in which ways textbooks actually are situated at the interface between the intended and enacted curriculum, that is between policy and practice. Yes, thank you. And so there were many studies on textbooks that I could name now. What I wanted to tell you is really that textbooks, in the same way as resources have changed, the resources have changed, for example, from particular manipulatives to others. Now, in terms of textbooks, when the digitalization came in, textbooks changed to e-textbooks. Now, I just talked to the colleague from Singapore, and we were talking about the e-textbooks in Singapore, and it's not only the access to the textbook, but actually also that how the textbook is used. And we know that from previous work on textbooks, that it's not just the access of the availability of the textbook, but actually how the textbooks is used in the classroom or maybe outside the classroom by pupils and by teachers. So we actually looked at these, at one of the e-textbooks in France, and that's a Césamat, the second one. And we compared it with a very traditionally well-known textbook in France, the Élise. And this was interesting because the authors of the traditional textbook were quite angry with us that we dared to compare this e-textbook, which to them was like a pile of bricks, and that's the word they used, those are the words that they used, with their well-developed textbook. Which of course the authorship was an inspector, as it is normal in France, an inspector, a teacher educator. The Césamat, the e-textbook, was completely, fully developed only in inverted commas, of course, by teachers. Césamat is a teacher association in France, and they started with developing resources for teachers, and then finally, and that over the years, developed textbooks. And these textbooks now take 20% of the market in France. So it's a huge chunk. And therefore, they can allow themselves to actually employ other people like ICT developers, which then work with them on the interactivity of the textbook. So textbook design and digital resources. We came up with very different perceptions of coherence and quality because of the digital nature of the textbook. And I think this is an interesting aspect which we developed further, where we investigated actually quality and coherence in mathematics textbooks, mathematics e-textbooks, and related it to design and use of those books. So e-textbooks are really, one could say, a different kettle of fish. They're not just textbooks as such, but in particular, if I went back to the Sesamat, and maybe the colleague can just click on the Sesamat. There you see, this is the web page from Sesamat. Everybody you can look at it, you could just type in Sesamat and you get this one. But what is interesting are actually the different kind of interactive devices that you can use. For example, Labomap, where exercises, the teacher gives individual exercises to pupils and so on. So these are the interesting parts, the interactivity with e-textbooks. There was also, as I told you before, a design process where they wanted to design e-textbooks, Sesamat, still the Sesamat Association, e-textbooks, and they for grade 10. And this grade 10 textbook, they wanted to make completely interactive. So they actually hired these IT specialists in order to work with them. So these are examples of where probably say Alison's talk and mine somehow go into each other, and where the digitalization or the influence of ICT changes a notion completely, the notion of quality, the notion of coherence in a mathematics textbook in this case. Also, maybe I should say that in Sesamat, a teacher can write in and change an exercise, beside, of course, changing it for him or herself on the worksheet, but actually also writing in to the authors, the 40 authors of the Sesamat Association, and change it. And sometimes you find a particular exercise or particular explanation different 4 weeks from now, basically, because they have changed it. So it's a little bit like a small Wikipedia, which again has interesting aspects to it when you think in terms of quality and coherence. So that was my presentation. I hope I have linked a little bit between Malcolm, professional development, where these materials can and should be used, and the ICT in mathematics education that Alison is going to talk about. Thank you.
Good afternoon, everybody, and many thanks to Cambridge Maths for inviting me along to speak this afternoon on a topic that I'm rather fond of. I'm going to address issues around digital resources in mathematics education, and in this short presentation, I'd like to try and highlight the particular influences that technological resources can have on mathematics education, and through some examples from both my own research and more widely, highlight why it would be rather naive to ignore the influence that technology is having on the content, progression and assessment of mathematics when you're developing a broad and visionary framework for 5 to 19. So in this presentation, just a brief overview, I'd like to give a sense of the digital resources from the perspective of mathematics education, a bit of a broad landscape, because we do have issues around what we conceive these to be that greatly impact on how people perceive that they can have an impact on teaching and learning. I will focus in on the digital resources that actually afford mathematical activity, the interactive mathematical environments. I'll give a couple of examples of curriculum assessment initiatives and also highlight some implications in the development of a flexible framework that is going to embrace technology within it. So in terms of how to approach this, it would be quite easy to start thinking about how you define the different technologies. But I'd like to stand back from that and think about the different perspectives through which we think about mathematics education and highlight a few technologies that fit with that particular view. Now, in all cases, depending on the resource, the digital resource you're using, it transcends all aspects of mathematics education, but some are particularly useful in particular contexts. So if we think about a psychological lens, the earliest bit of technology that I can trace is back to Skinner, who created a mechanical learning machine about 55 years ago, which was very innovative in its day. And essentially it was individualized scheme designed by the teacher with the student writing a response, turning a handle and being given the feedback of the answer. And this was a very sort of Thorndike stimulus response view. And it was all about motivation, engagement, instant feedback. And that was something that fitted very well with Skinner's perspective on mathematics education. We do have a modern day equivalent. Now, I'm being harsh here. We've got no idea actually really what that child is doing there. It may well be something creative. I'm using the image because it may also be something where essentially, and we did see this in the images in the opening video of a student putting in a numerical response, getting either a carrot or a stick, depending, and maybe in a more sophisticated way some feedback. But that stimulus response mode is still prevalent. And when you look at the research into the impact of this, much of it is around how it influences the motivation and engagement in mathematics education. So it has a place. That's not what we're going to be interested in for this framework. Another version overlaps with another theme that I'm going to bring in, but these are the clickers. These are, again, it's a motivational way of engaging children. It has a place, but that's not what I'm going to be talking about. We can think of it from a socio-cultural perspective. So how is it actually influencing the way that students engage with the mathematics that they're doing and the way that the knowledge is developed in communal ways? This is a lovely example from a piece of software called Group Scribbles, which essentially turns plastic wipe-on, wipe-off whiteboards, which are quite prominent in the primary classroom, into an electronic version, throwing their responses up onto the board for communal mathematics to take place. So it can be around sorting and ordering and classifying, but this is allowing the students' knowledge to come up to the front and be mediated by the teacher, supported by the technology. Another use, not what I'm interested in. Upper secondary, this is a more sophisticated version, mobile devices for science and technology that do highly mathematical things, throw them up onto the board for communal mathematics, discussion, sorting, explaining, etc. There may well be lots of really good stuff going on individually there, but that particular use, not what I'm interested in. Visualizers, fantastic. Kids do manipulative stuff, come and show, everybody can see, but it's not what I'm interested in. Online platforms, exchange, yeah, communal maths, arguing about it, great stuff, has a place, not what I'm interested in. Back to this one, because actually that's highly socio-cultural, isn't it, in terms of that doesn't look like a normal mathematics classroom there, not what I'm interested in. So what am I interested in, and what should we be interested in? It really comes down to how the software is really allowing us to think about the cognitive aspects of learning mathematics. What's the nature of the knowledge that that particular technology is affording? So this is where we pay tribute to colleagues who've been developing software 10, 15 years in development. This is Jim Cappett's SimCalc, which is an interactive environment that allows exploration of function, and it has a modern day equivalent, which is a project that I'm currently involved in, Cornerstone Maths. So this is about taking very tried, tested and researched uses of technology and looking at how they fit within the current context on a large scale. Seymour Pappett's work, so that's again thinking about how the technology in the hands of the students is enabling them to be creative around in this case, their modelling scenarios with Lego models and some basic programming ideas. And this is very much about touching. We have iPads and we've got the opportunity to touch, but what actually are we touching? Are we touching and manipulating mathematical objects? A key element that can come into play when we've got that sort of technology. So, in thinking about the challenges that we have ahead of us, what sort of criteria might we apply if we're actually thinking about which technological resources might be interesting? And with that in mind, how should the mathematics curriculum change in the light of that? What challenges does it present us with if we're thinking about assessing mathematical knowledge in these environments? And how are the traditional notions or pathways of mathematical progression challenged? So I'd like to actually share some examples. This is an example from Cornerstone. And what I'm going to ask you to do is just watch the animation that I'm about to play. I'm interested in where your attentions go. So think about what you're actually watching as this animation begins to play. And play it again. If you didn't already, notice the graph. I'm going to give you another representation. Going to give you another let's just play with that one a little bit more. What happens if we step through second by second? Let's have another representation. We've got our heads around what's happening here. Now let's play. Now let's think about changing that scenario and observing the impact of editing different aspects on the animation, or the table, or the function. Depends what you're looking at. Let's try a different way of editing. And then let's do what kids do. Let's try and break it. But in a highly mathematical way. That's a negative 50 if you can't make that out. Bye. Okay, now that's a digital environment. Within Cornerstone, it's very much embedded within curriculum materials that have been designed and trialled in collaboration with teachers, and it comes with professional development because very much relating back to the points Birgit was making, that we've got a resource here. We've suggested some ways of using it, but it's supportive to think through and plan how each teacher is going to use it in their particular classrooms for their particular context. But as a research team, we're really mindful of an aspect that Mike mentioned, which was around this idea of adapting out the critical elements of this software that we think supports the mathematical learning. So with that example in mind, if we think about the traditional progression in terms of linear functions, very much we start with a function, we generate a table of values, and we produce graphs. Yeah, that's the common route through, and then we get to the graphs and we start to look at them more in a deeper way, but you've got to get that route through first before you can get to the graph. If we think about the opportunities we had there, because of the facility to edit different elements of the system, we can start with the function, which leads to the graph and the animation. We can start with the graph, which leads to the animation and the function, or we can start with the animation and end up with the graph and the function, all of which produces this table of values. But we've suddenly got different routes in, and depending on where this sort of activity is introduced, you can be thinking about how it is that particular learners can meet some of that mathematical content at different ages. Another example, and this is taking it right down to a primary level, getting a feel for two-dimensional shapes. Now, I hope you agree from where you're sitting, they look fairly equilateral. This is a very simple construction in a dynamic geometry software package that was developed at least 15 years ago when interactive whiteboards came on the scene for use with very young children to play with shapes. And the idea being that they would pick up vertices or just basically see what they could move around that. And from that, essentially thinking about what stays the same and what's different in that scenario. And depending on how those are constructed, it will start to reveal the mathematical features of particular two-dimensional shapes, in this case, triangles. So there's a very different experiential approach to meeting shape. It's not the naming of shapes, it's actually by playing with them in a dynamic and interactive way, thinking about how it is that those particular shapes are called what they are called. There are examples out there of curricula that have addressed the large-scale examination of particular aspects of dynamic geometry use. And Ontario was a great example where there was a province-wide purchase for all schools. The curriculum was developed to integrate it. There was some early professional development for teachers. There was a province-wide school-based assessment task that required the use of dynamic geometry software. Now, this was in 2000. It was 3.5-inch floppy disks being moved around classrooms. There was no internet. There were a lot of, if you like it, you could say it was ahead of its time. There was a framework in terms of assessing aspects of the technology use for mathematical purposes that was accompanying this particular assessment. And the assessment itself was very successful in that it enabled teachers and the province to make statements about the children's mathematical understanding, but the actual enactment of it was a nightmare. Floppy disks, teachers who didn't quite understand exactly how the dynamic geometry software, that instrumentation phase was longer than they'd anticipated in terms of making the most of that opportunity. So it ended. That was 15 years ago, and that's where that ended. So as far as we're concerned, implications for us are around professional development for teachers, is around how when you begin to use even the most simple environments, how it impacts on the mathematics you're going to teach, how you're going to teach it, and the assessment that goes alongside that. Do we decide on classes of technologies or particular technologies? Classes of tasks or specific tasks? And do we ever think we'll get to a point where mathematical technology use is embedded as part of key assessments or examination systems? So, some questions for us. Thank you very much.
It would be interesting if you can leave those questions for us up on the screen, because we may want to bear them in mind as we open conversation and debate. I think the last one was about how do we think assessment ought to respond to the technological introduction into pedagogy in the classroom, and we may pass that one on to the next session to deal with. So maybe we should first focus on the first three questions. And I think the first one was around to what extent do we think will professional development be impacted on the change of pedagogy in the classroom, and what is the support that teachers require? Maybe that link into the previous session we had. So any further responses or reflections that you have had over lunchtime? There is a comment from Jeff Wake, who is actually in the audience, I think, which I'll take after we dealt with this maybe, because it is taking a different line. So let's just see whether, are there any further responses from Simon Liebes, the Chief Executive of Cambridge Assessment?
I don't have a response, I just have a question. We spent the last session this morning talking about some of the challenges associated with teacher development and training using traditional means, and this adds a sort of further pretty extreme variable. And I'm just interested in what the approach is to equipping teachers, because already are having this technology, and clearly it allows you to approach maths education in a very different way, but you can't do that unless you've got a fairly well-developed body of practice and well-developed set of teacher skills. And I'm interested in how you addressed that, given some of the challenges we were talking about this morning in addressing more traditional deficiencies in teacher training and capability.
Yeah, a couple of comments. Earlier on, a couple of people talked about what motivates teachers with respect to their own professional development. And one of the things that has changed in teaching and continues to change is both access to and opportunities for developing how technology is used. I don't think you'll go into a school where a principal will say, no, we've actually decided not to go with technology. We think we'll stay with where we are. So it's something that is in most teachers' experiences. Schools invest in software, they invest in hardware in terms of tablets and whatever. So it acts as a lever in that respect, in that it's something that teachers are interested in finding out more about. And secondly, I think the impact that it can have on mathematical subject knowledge is another area where, maybe not initially, because you've actually come along to maybe learn about some technology, but in thinking about either on the design side, designing activities within a particular software, GeoGebra say, or sorts of things that are being used in schools, that process inevitably leads you to think more deeply about the mathematics and alongside that, the sort of pedagogies that might accompany that. So on the one hand, you would think it would be the last thing in line, but actually it's of interest to a lot of teachers, which makes that a little bit easier. And in terms of the models, really Malcolm's the second model of the sort of experiential, over time, work on something, try it in your classroom, come back and discuss the outcomes, introduce those cycles is really the model of professional development that seems to be more successful in terms of supporting teachers to develop practices in that way.
Does that answer your question, Son? No. Do you want to stay on professional development for now? Yeah.
Yeah, if I can link together professional development and resources in terms of that point that was made about... stand up the cameras. Oh, so sorry. Yeah. In a sense, adapting out. Maybe the underlying principles, maybe we're trying to actually have a resource that is picking up some of the misconceptions. And as a teacher, we have very much a superficial idea at times of what the resource is there for and doing, and we adapt it in a way that actually removes some of its essence, and how our professional development actually enables us to retain that essence, maybe by telling us something of the reasoning behind the resource as well as the resource itself.
You want to respond to that?
Well, I think that some of the resources are developed by teachers, or at least co-designed by teachers. So your idea of basically telling them about it's not telling them about it, it's helping them to experience this design in use, co-design and so on, which I think has exactly the, I mean, you need an experienced or teacher educator so who is working with it. That's why I think higher education or experienced teacher educators come in. But it is, of course, the collective work on these resources and designing, redesigning, amending them, appropriating them, simply interacting with them, that is on the line of teacher learning. I mean, it's the same for digital resources or other resources. So in a sense, the interaction with resources is the thing which is at the heart of the matter there. And one important aspect is, or one could ask, is it better to work on your own? For example, teachers, when they develop their lessons, they develop resources, curriculum materials and so on. Should that be done on their own or in collectives or collaboratively? And we think in terms of the research that we have done, and I think all other research says that it is always better to work in a collective. You know, you just have, you have so much I think in a collective, teachers work, develop much better these kind of what I would call didactical flexibility. This is not an English word, of course, because didactics is not, it's more European, but you know what I mean. Sort of the flexibility of the mind to think about the teaching and learning in different ways. So maybe I could call it didactic flexibility.
I'd like us to return to the question of technology and software developments that's been around. And Jeff had an interesting question that he posted on Twitter. So maybe, Jeff, you want to repeat that while you're here.
Okay, I'm Jeff Wake from the University of Nottingham. And the question asked was about dynamic geometry, which I didn't know that Alison was then going to show us the use of dynamic geometry. But it seems to me that both Birgit and Alison have talked about technology in a way that it illustrates it can provide a step change in what happens in terms of teaching and learning. And importantly, I think it allows you to develop a new epistemology of the subject. And I wonder how a framework can capture that potential and possibility. And to link to what Malcolm said just before lunch, that how do you have an evidence-based framework, but that has a vision? And I would, personally, I would like to see technology, the potential of technology being available through the framework, that you can capture a vision of what it is we're going to be able to do in the future. So it's a question really about how something that's at the moment quite static can actually be dynamic in its response to developments in teaching and learning and the nature of the subject that we're involved with here, which is maths.
Want to add to that, or do you want?
Yes, my name's David Trenaro at Cambridge University Press. I had a sort of similar question, actually, and it was about timescales and environment. As a publisher, where we have been used over the years to working on a specific timescale against a constant environment or a reasonably constant environment, and I think that's also been the situation in education too. But increasingly over the last few years, we haven't been in control of that environment. The environment has been changing much more quickly than we're used to. And I haven't got a solution yet for how we might adapt to that, but I think it's something we ought to be considering here about the timescales over which we're doing things in order that we can actually say something sensible whilst our environment is still reasonably constant. That's all.
Well, if I may, I would like to add one further dimension of that into the mix, and that is, do we think that curriculum development has kept up with the pace of change as much as we feel it on the resourcing side as well? Any response? Someone, you want to respond to that first?
Shall I? Yeah. I think this is an interesting question, and for me, it links to working on your own and sort of trying to put all the factors together and making it happen, or do you actually try to find, and Mike would say, a dynamic balance in the terms of complexity thinking, dynamic balance between what people work when they work collectively. So, for example, this e-textbook, the Sesamat e-textbook, when you think of it, what is the quality of this e-textbook? It's definitely not a static quality, because the static quality is in a traditional French textbook, and it's very well developed. It's called Helix, and it has this helix structure and so on. But it has a different kind of quality or coherence, because the teachers are actually contributing to it, and a large number of teachers have developed this book. So in other words, you know, you can then say, well, what kind of quality is it then? Maybe it's a dynamic quality as compared to a static quality. So what I'm saying is that the digital affordances force us to change our notions of particular things, and it's, I think the same is with when we walk along and say, do we have to produce this, do we have to produce that, and so on. How does it run away? Sort of like the virus who mutates too many times before we can actually make a vaccine against it or so. Well, it's a little bit that situation, isn't it? And I think it's not a matter of running behind, because what we are still trying to do is put all the things together, and you know, the sum is more than putting all its parts together. And that's when teachers working together, you get more out of curriculum development and so on than when the original curriculum developer decided on a curriculum, implemented it, tested it, and then it became. That is the curriculum development, the old curriculum way, isn't it? And that's where the terms of intended and enacted and assessed curriculum came from. But now it's different. It's more dynamic, and it can be put upside down. And I think we have to let this happen with teachers and teacher educators working together. And then I think we might get a kind of dynamic balance also in this respect.
Of course, the ingredients don't change. It is just the way in which you make a dynamic that changes.
Isn't that what was just saying, that in part, if you go for evidence-based, well, what you're saying is staying ahead of the game, which is sort of almost counter
the evidence-based.
I mean, there's a particular difficulty with researching technology in that it really doesn't stay still. And the T word for technology is actually too big. We need to be far more specific. I mean, even talking about particular technologies, dynamic graphing software, dynamic geometry software, is still too big. You need to get down to the task level to think about the particular ways that the mathematics is encountered in that particular environment, to be able to think about, then come back from it. So, you know, studies that just say, you know, what impact can GeoGebra have on, we'll never quite get where you want, because there's too many ways in which that particular software can be used to cover all manner of topics, and it's very difficult to reach any conclusions.
Can we take the question at the back, and then maybe, Lynn, you can think about this question in the meantime as to how do you balance the evidence-based with future vision, and give us your perspective on that towards the end of the session.
Birgit, you contrasted a French textbook with an e-resource in France and said that the e-resource now is 20% of the market. Presumably that means that you can do quite good comparisons between how effective they are in actually helping children to learn mathematics. I didn't hear you say that. I mean, what evidence is there to say whether one is better than the other?
I don't quite understand what you're trying to sorry, say it again, please.
The textbook and the e-learning resource are both there to help children learn mathematics more effectively, presumably. There's a large body of students using both of those different mediums. Which one is more successful in terms of improving teaching and learning for the children?
But there are more variables in the equation than just the textbook or the e-textbook. I mean, there's one big thing is, of course, how the teacher uses this e-textbook. And we, for example, one of our teachers, or several, but she in particular, she uses the Sesam book for particular things, but she uses all the other textbooks or some other resources who have other interactive resources for, you know, to build in her lesson preparation.
Okay, so it's complicated, but... I beg your pardon, sorry, is that better? Okay, I can appreciate it's complicated, but presumably there must be a way of assessing actually whether it's valuable or not. When you've told us about this thing, which is very popular, clearly. I'd love to know how it works. When you're saying there's lots of variables that make it complicated, I fully accept that, but that's not really an answer, is it?
Yeah, I mean, the other thing, the other reason why it could be successful, it's because it's half the price of a normal textbook, you know. So that would be a very, very flat understanding. But still, it is important in England, in the UK, as well as in other countries, the price that you pay, because in France textbooks are provided for pupils, and every 4 years the textbooks get renewed. So if teachers have a say in this.
I think the question is around, have you done how long has this been in the market, and has an impact study been done on assessing the effectiveness of that? Do you know whether that has been done? Or?
No, I don't think, I mean, it's the question, what means effectiveness? You know, does it mean, are you looking then at national test results, for example? And as I said, teachers use different resources, not only one textbook. And so an effectiveness study would need to keep constant all the other variables. So how, I don't at the moment see how that could be done.
Okay, so how do we know whether it works or not?
We don't know that it works. I have not said that it works in terms of attainment. I have said that it works for teachers, because teachers develop a different kind of agency when they work with a book.
Is education about teachers or about the outcome of children? I'm confused by your response.
Well, and I'm confused by your question.
Saying is that there hasn't been a scientific impact study on this, and it is difficult to draw conclusions from that. But I think your point is well taken, that it has to be done in order to determine what the impact of that would be. It's an interesting concept to think about dynamic resource development involving your end users, whether they're teachers or students. But yeah, it would be interesting to see. Let us know when an impact study, maybe there's someone in the audience that would like to steer that impact study.
There's something that changes, that's continuously changing. Yeah. How do you want to make the impact study? And I think I cannot see at the moment how that would be possible with this e-textbook that changes.
Can we take
like a
first and then Mike?
Yes, thanks, Hanri. Tim Oates, Cambridge Assessment. Just a couple of reflections on. Yes, just a couple of reflections on that very important exchange, I think, from two examples drawn from transnational studies. The first is Finland, and Gabriel Saugren and I have been looking very intently at Finland, not at how it is now, but how it was during its period of improvement, and during its very rapid improvement during the 1980s and 1990s. It's very interesting to contrast the role of textbooks during that period and teacher handbooks, and the way in which materials of the kind that you were referring to, Birgit, are now being put together in Finland. And one might want to contrast different periods of development of education systems and the form of the materials in these different periods and the way in which they're used. It's very clear that people are kind of conveniently ignoring the fact that centrally approved textbooks were very central to the transformation of Finnish education, that all materials were reviewed. They were reviewed by very young children as well, actually, during that period, to make sure that they embodied fully comprehensive education and didn't return the system back to more segregated education, which was a very deliberate move in the system. So all materials were reviewed to see whether they embodied the ideas of the central transformation of the Finnish system. Very, very interesting. Use of materials as a transmission of fundamental underlying ideas of ability, of grouping, of the sequencing and progression of material. Most recently, Finnish materials have been developed in a very, very interesting way, along the lines that you're describing, Birgit. But it's also a time when the standards and outcomes in Finnish education are plummeting. And I think we've got to look at these stark realities to see what the purpose of these mediating instruments actually are. Very briefly, the second example I can summarise much more quickly, and that is a very interesting study in Singapore, where the functions which are currently supported by one of the most popular set of teacher support materials and student workbooks it was a pilot to see whether they could be replaced with electronic analogues. And after a very short period of time, it was clear that the same range of learning functions and outcomes, Charlie, were not being supported by the electronic versions of the same materials. Now, that's being currently looked at, but it was very clear that it was not the same thing was happening in terms of an almost direct electronic analogue of the existing, well-established, incrementally improved materials.
Thank you. That's an interesting perspective. Can we take this question and then we'll take the one at the back?
Mike Askew. I wanted to pick up on something Birgit said, which I'm not sure this is what you meant to say, but it's what I heard you say, which was kind of teacher-developed materials are good and centrally developed or professionally developed materials are bad. That's a gross caricature, I know. But I think, and I was at the same conference that you were at in, wherever it was, I can't remember now. No, in... wherever, where we're looking at task design. And I think one of the things that came through there is that those of us involved in mathematics education, I think some of us, and I'd probably include myself in this, have this kind of wish that most teachers were involved in task development, in resource development. And I think the reality is that most teachers aren't. They don't have the time or the capacity in terms of resources to do that. And I think we need to think about how we help teachers make better choices. And all too often it's kind of, this was developed by teachers, it's electronic, it must be good. It's also half the price. But it's about being kind of sensible. I don't want to use the consumer word, but I'm going to use it. It's kind of being sensible consumers of resources, I think we need to think about as much as developers of them.
True.
Hello? There we go. It's Dan Thomas again. There are other people who talk. It's not just me, I promise. I kind of want to come off both of those, really, because I don't have time to produce things that I'd like to. It's very much a case of there's no time to reinvent the wheel. Let's see what's there and adapt rather than invent. So that's just to back up what was said. If I can bounce off Tim's statement, I found that really interesting, that the e-textbook isn't producing the same range of outcomes, and my own practice would back that up. What I think is interesting, though, is why are we looking for an electronic equivalent of a textbook? What we need to be looking at in an e-resource is what does the technology, and I completely agree that's too big a word, but what does the technology allow us to do that the print medium doesn't? What I'd love to play around with, and again we're coming back to time, is more of a blog environment in the classroom where students can share ideas, can share discussions, can share problems, and can look at coming at a rich scenario using the technology which they know better than I do to try and put together some solutions. To me, that's a better use of technology. An e-textbook, what's the point? Technology must be able to progress past what the print medium has. There must be some unique benefit to using it, otherwise why bother?
Adding to what you say, we just had a comment from someone who is watching this on the web, from a guy called John Mason. Oh, is it in the audience? No, oh, okay, but you obviously know him. But he said he's fascinated by our conversation as to how we focus on the use of materials to complete assessment tasks. And what he's much more interested in is to know how do you establish and maintain productive ways of working and changing behavior of students as a result of using resources, which is kind of linking to what you're saying as well. So any response to that? You were, Tony?
I'd like to link to the last 2 points. I'm rather sorry that none of my colleagues from Enrich is saying this, but since none of them are, I will say it. What Enrich has offered for the last 20 years has been resources to support the teaching and learning of mathematics. And that's been done in a different way as time has gone on. And I'm looking forward for the next 5 years with Cambridge Mathematics to think, how will that change in the next 5 years? Now, where this gentleman over across there was talking about the teacher's perspective. What your e-resource, what Enrich offers, is interactivities, we called them. That is, the learner, the student, can try something out online and see what happens, and then think, why did that happen? And then try something else, and then discuss it with other children. The teacher can conduct a class discussion where they're focusing on this particular interactivity. Now, that's something that you actually need quite good bandwidth for. I've actually worked in South Africa a lot and have been exercised by what is not available in the classroom there if you haven't got good internet bandwidth. But your blog, which again you mentioned, doesn't require that bandwidth. And I'd like to say that I've seen in the last couple of years a huge change in the developing world as it's been possible to use the mobile phone to access the internet. So now it is becoming accessible to more teachers who can have a conversation about mathematics. So I want to go back to Enrich, because Enrich is rich in tasks that the learners can do, and it's much richer in a sense than the e-textbook. Well, the e-textbook can be a lot of things, can't it? But is richer than your printed word, because it's offering that chance for the learner to engage with, try something out, see what happens, learn from it, discuss with other learners.
It's a very valid perspective, but we've got 2 minutes, and Lynn, I'm not going to let you off the hook. Let's take that one question, and then I'll refer back to you with your response.
Hi, Nick Sample, representing CUP. I think the point I'd like to make is that rather than thinking about what digital has to offer versus what print has to offer, I think it's in many cases more helpful to start from the outcome that you're trying to achieve and think about the tools that both can offer in achieving that. So there need not be a divide between print and digital. And to the points that I think David made about timelines, technology is always several steps ahead of where you think it is. Because when we're talking about technology, we're talking about something that's global. So all the things that are happening in California, across the world, and are being innovated on to be released later this year or in future years, always several steps ahead. I think the key is to innovate and to adopt a very agile approach to product development, and that means ignoring some of the old orthodoxies and simply putting stuff out there often, quickly, ready for scrutiny. People can accept it or reject it, but just get on with it rather than working to very long textbook-style schedules, essentially.
You just summarised exactly how I wanted to close, but it gives us the ability to rethink in the way in which we do things and to adopt all those approaches. So thank you for that, Nick. No, I don't need to do that. So a final perspective from you, Lynn.
So Nick, thank you very much, because that gave me a wonderful answer to give to putting me on the spot. Absolutely, I think that the framework needs to be evidence-based. There is lots and lots of mathematical research out there that we can learn from. However, one of the points of us having 4 partners in this is that we also have partners who can be innovative and who can be agile, both in their product development and in their product placement. And I think that that's where we can actually hopefully bring together the two things. Just like we don't have to have a distinction between the print and the digital, I don't think we need to have a distinction between the research evidence and being innovative. Well, that's what I think at the moment, anyway.
Thank you for that, Lynn. And to our 2 panelists, thank you so much for your input and stimulating ideas this afternoon. We now have a tea break, and it's indicated on your program when we should be back. Well, great. You were great.